Today is the second day of review for the cumulative. There were two parts, probability A and probability B. So yesterday we did the probability A review part. So that ended with this kind of a question. I want to like wrap up that part. So I'd like you to put piano, cow. Not going to be too many people that are going to be able to answer yes to that one. And dog. There'll be a lot of people that can say yes on that one. And there's people that don't have a piano, a cow, or a dog out there. All right. Okay, cow is a little too far of a stretch. Probably, maybe there's one kid. I don't want them to feel singled out. So maybe I should pick something more common.
Fish.
Like, what?
Fish.
Oh, okay, that's an interesting one. There's not that many fish people, but there's definitely more fish people than cow people. Okay, you have a piano, you have a fish, and you have a dog, then you go in the middle. Get the idea? All right, so you're in only one of these spots, you personally. Would you please raise your hand if you are in this spot, which means you have a piano, but not a fish and not a dog. Piano, but no fish, no dog.
Oh, yeah.
Okay, 1, 2, 3. All right, everybody write a 3 there. This spot would mean you have a piano and a fish, but not a dog. Oh, okay, so we're going to change this to 2. And then I'm going to ask again, piano and fish. All right, anybody else? All right. How about fish, but not a piano and not a dog? All right. Turns out the fish weren't super popular. They were more popular back in the day. How about you have a piano and a fish and a dog? All right. Does anybody have a fish and a dog? Ooh, cool. And how about a piano and a dog? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Thank you. And how about a dog, but not a piano and not a fish? 1, 2, 3, 4, 5. How about none of the above? 1, 2, 3. All right. Now let's add them all up, and you guys see if you get the same answer as me. What'd you get? 25, I agree. 25 people total. Now, here's a easy question. What is the probability of piano, union, fish? And here's a hard probability question. Given dog, what's the probability of not fish? That's fish with a little dash. That means not fish. All right, start with the easy one. Probability of piano, union, fish. Remember, unions want to be big. Union means or. Ors are big answers. All right, if you get an answer for piano, union, fish, compare it with the kid next to you and then tackle the red one. Much harder. All right, I'll tell you the piano, union, fish one. Union is an or, and ors are big answers. So it's all of these, because if you asked any of them, do you have a piano or a fish? They'd all say yes. So that is 13, 14, 15, 16, 17 out of 25. Raise your hand if you had that one right. Okay, cool. Then we have the other part. Given dog, I'm going to circle this in red. These are the only people we can talk to now. If you grabbed any other numbers, you're doing it wrong. Probability of not fish. This is not fish, this is not fish, and this is not fish. So the grand total really just has the one extra that, so this is, I'm saying this badly, 18, 19, 20, 22, is out of 22 because there was only 22 dog people. And that is interesting. 22 out of 25 of you have a dog. Holy cow. Did I do that right?
19, because the 3 is none of the above.
Oh, you're right. You're right. The dog people, I screwed up. I done screwed up. Sorry about that. Okay, so the dog people, I gotta stay inside the red circle. You're right. 15, 16, 18, 19. There is 19. 15, 16, 18. Yep, there's still 19 dog people. So that's 19 on the bottom. And then not fish. All right. Of the ones inside the circle, inside the red circle, the not fish is the 13 and the 5. So that's 18 out of 19. That make sense to you?
How did you get not fish?
Because that fish has a dash on it, and I said not fish. And how did I pick those numbers? Because look at inside the red circle, and which of them do not have fish? 13 and the 15. All right. Now, on the probability B test, I'd say the hardest thing was probably CC over C. So I'm going to give you one like that. In this classroom, there are people who are wearing white shirts and there are people who are not. If your shirt is mostly white, would you raise your hand so that I can count you and go 1, 2, 3, 4, 5, 6, 7 people out of, we already established there's 25 of us in the room, 25 kids. There's 25 kids and, did I say 7?
Yep.
7 white shirts. It's not 25 and 7, it's 7 of the 25 kids are wearing a white shirt. Okay, so now here's my question. If I grab randomly 3 of you, if I pick 3 people by like rolling dice, what's the probability I'll get 2 white shirts and 1 not? 3 chosen. What's the probability? 2 white shirts. So, if you knew that this was a 25 right here, raise your hand. Yes. If you knew that this was 3, raise your hand. Okay, good. If you knew that this was 7, and you knew that this was 2, and you knew that this was 18, raise your hand. Okay, good. And then what's left? 1. All right. Now, actually, you put that all in the calculator and divide it out. You get a decimal. Being honest, I was helping a kid and I don't have time. I didn't have time, so I haven't got it, but I bet somebody does. Who thinks they got it? What do you think?
I got 0.164.
0.164. Now, I had a lot of kids who had the right answer, like right here, and then got the wrong answer. If that just happened to you, you've got to do something different, you know, if you're not getting the right answers. Now, I think he's right, but I'm not sure. Who else got 0.164? That's a lot of people. That's probably it. So if you're like, wait a minute, why didn't I get that right? Here's a way I bet I could fix it for you. If you put in parentheses here and here before you do your answer, I bet you that would fix it. Okay, so if you have trouble typing that in, ask me. All right, the next kind is blanks. Let's say it's your classic license plate and you can put in letters or numbers. Okay, let's say that it has to have a letter first and it has to have a number last. But that's all the rules that there is.
So there can be any number in between.
Any number or letter in between. But I'm not done yet. That's one thing. That's how many ways. That's not a probability. Do you get that this is going to be a really big number? And therefore it can't be a probability. Okay, so then you divide it by, what if you're trying to figure out what's the probability that there'll be a letter first and a number last? So then what do you divide by? Well, then it's the same thing with blanks, except anything goes. Like on the top, we were trying to, what we wanted was a letter first and a number last. But what's possible was anything could have happened. Would you please figure out the probability that you'd get a letter first and a number last? This is not just blanks, it's blanks divided by blanks.
Yeah, I got the same numbers. Finish by it. Like 10-0-1.
Carter, how many letters are there?
26.
Do you agree that there were 26 choices there then? Why is it 36 here?
Because it can either be a letter or a number.
Good. And also 36 here, and then at the end it has to be 10. And some people are like, there's only 9 numbers. No, you can count 0. So there's 10 numbers. Good. And then on the bottom, anything was possible. So then it's 36, 36, 36, and 36. If I was typing this in the calculator, I'd let this cancel this. It would save me a ton of time. Know what I mean? And I'd do the top in my head, and I'd say 260 divided by, and no, I don't want to do the other part, so I'd use a calculator for the rest. Okay, so I'm just trying to show you, you don't have to be a slave to your calculator and type everything in, because if you type one little digit wrong, it would have been way faster to just cancel these. All right, so it's 260 divided by some huge number, and then what's the final answer, Brody?
I got 0.201.
Anybody verify 0.201? Okay, awesome. All right. So what else do we have? Expected value. So you remember the reach into Mr. Server's wallet game? I have different bills in there this time. Do you get that if I'm going to give you a bill, it's probably going to be worth it to pay $1? Okay. But if I said I want to charge $50, then you get to draw one bill out of my wallet. It's probably not worth it. Unless I have 100 in there, maybe. All right. So you're trying to figure out the worth, the expected value of a draw. So I'm going to tell you there's two 50s. One $10 bill. And one $100 bill. We've got a probability. It's not super clear, but you can figure out the probability you'll get a 50. And then the amount is 50. And then you got a probability of a 10, and you times it all up. Add P times A, then add, and figure out what you think the answer is. Maybe it was worth $50. In fact, I think I'd play that game for $50. But I'm not charging anything. To start with, just figure out what's the value if there's no cost. The game is free. Under's taking the headphone. She can have headphones because she's taking a test. All right. Tate, what's the probability of getting the 50?
50%.
Because it's 2 out of 4. Very good. 2 out of 4 times the 50. Okay, good. Then it's 1 out of 4 times the 10. And then it's 1 out of 4 times the 100. And I could do these in my head faster than you can on the calculator. Half of 50 is 25. Half, or 1/4 of 10 is 250. That might have been hard for some of you. 1/4 of 100 is 25. That makes it worth $52.50. Now, that's the expected value. Other than considerations like I don't gamble, therefore I would not play. If I charged $50 to play, what the heck does the $250 tell you? You should play. Your expected value is positive. You'd win in the long run. Make sense? All right. Would you win every single time? No. Sometimes you'd win, sometimes you wouldn't. In fact, it's actually pretty close. It's really only a difference of $2.50. So paying $50 and only winning $2.50 is kind of risky. All right. That's expected value. And then how about making a number that's got like a certain size? let's say we have a 3-digit number. Would you agree it's pretty easy to have if I get a random one, it's pretty likely it's going to be above 200? Do you agree that the number being above 200 is pretty likely? Okay, figure out the probability that it will be 200 or bigger. I just changed it to a probability instead of how many ways, but the probability that the number will be 200 or bigger. If it's a probability, you better be dividing by something.
What was it, 1 to 10?
And there's one more kind of problem we need to explore, and that'll use this, and I'm just trying to make myself remember to talk about it. You know, choose something, and then you use like 0.75, 0.25, that kind of problem. That's called the binomial. We don't use that on the problem we just did. I'm just reminding myself to do one last like that at the end, because that's definitely on your test again. I mean, actually, I haven't even looked, but it was on your previous test. Very likely it'll be on the cumulative. Okay, Martin, how do I do this choices thing where I want it to be 200 or bigger? Leah? How many choices do I have for the first number if I want it to be 200 or bigger? How about this? Would a 2 work? If I put a 2 here, wouldn't the rest of the number have to be 200 or bigger? Yeah, it would. So a 2 would work. Would a 3 work? Would a 4? 5, 6, 7, 8, 9. That's 8 numbers. So there's 8 choices that would work. Does that make sense so far? Oh, 7? Sure? You could start with a 0?
No. 2, 3,
Okay.
4, 5,
2, 3, 4, 5, 6, 7, 8. No, you're right. It's only 7. I counted wrong. 2. Can I start? 2, 3, 4, 5, 6, 7, 8, 9. Oh, dang it. I was right in the first place. Okay. 8 choices. Right? Okay. Then the other numbers don't matter, because if I start with a big enough number, then the other numbers don't matter. So what do I put? Nothing? No, I get all the choices, which is 10 and 10. And on the bottom, anything could happen. All the possible things. And that is 10, 10, 10. Now use canceling. That cancels that, that cancels that. The answer is 8/10, 0.8. Boom, done. No calculator needed. Make sense to you? 80% chance. All right. Okay, now this kind. Let's say that you're breaking in pool. How many of you guys have played pool before? Okay, good. So you break, you got them all set up in a triangle, and then you smack the cue ball into them, and it breaks them up, and then there's a chance you're going to drop one. And let's say you're pretty good at this, and so you have a 75% chance of making one when you break. And if you make one, then that means you get to hit again. Okay, so this is miss. Now my question is, if you had 3 chances to break, you're over at your brother's house and he's got a pool table, you got 3 chances to break, what's the probability you'll get 2 times where you drop one? 2 times where you make it. 2 out of 3 tries. You drop one on the break. Well, if you put a 2 here and a 3 there, your calculator will just say error. You can't do that. You could put a 3 here and a 2 here, though. And Brody, just tell me how to do the rest of the numbers. What goes above the 0.75?
Square root, or not squared.
Squared, yes, because that and that should be the same. And then I was surprised how many kids didn't know what to put here. There's got to be a total of 3 shots, so there must be a 1 there. All right. Chase, could you shut the door back there, please? All right, now it's just a matter of typing that into the calculator, getting an answer. Becca Rowan, what did you get when you typed it in?
0.422.
Anybody else get 0.422? Lots of people. Okay, good. So there's about a 42% chance that you'll drop a ball 2 out of 3 tries. But there's something even better than that. If you made all 3 of them. Take a second and just change this to making 3 out of 3. There's a reason I'm asking you to do that. If you type this all into your calculator, that's kind of dumb, because this part's 1 and this part's 1. So you probably can just put in the 0.75 to the third. So it's not real likely you're going to get a ball to drop every time you break. The answer isn't very big. Tate, what'd you get?
Oh, so
Type it in, 0.75 to the third.
same thing.
0.75 to the third is 0.422? Is it seriously?
Yeah.
Wait a minute. Okay, I'll believe you. It just doesn't make sense to me, but I guess it's because our expected value, 2 out of 3, is like, it must be right between those two. Our 75% make chance must be in between those two. And it is. So I guess that kind of works. Do you get that there's an 84% chance, 84% that you'd make at least 2? Because that's 2 or 3.
Is there a change?
Hold up. I'm recording. Okay, so then last question. What's the probability that he won't make at least 2? If there was an 84% chance that he's going to make at least 2, what's the probability he's not going to make at least 2? Anybody agree with 0.16? Yeah. 16% chance. If I make this a 0.84, it might work better for you. Why? Because if this is the chance it's going to rain, this is the chance it's going to not rain. You just subtract it from 1. All right. Okay, there's enough practice. Now, it's up to you. You have a worksheet, which is like a practice test. Strong recommend you do the whole thing, and there's an answer key for it, and then you'll be really, really ready for tomorrow's test. Could you, in the rest of this hour, work on some corrections so that your retake would actually count? Yeah. Remember, if you get 100%, but you can't replace it if you didn't do the corrections. So you won't be able to check the box because you didn't do the corrections. So if you have anything that you want to correct, you better do that, because getting a good score doesn't count if you didn't do the corrections. I mean, it'll count on the test, but it won't count as a retake. All right, that's all I got for you for today.